Hello, this is Group 17. I am Richard Saco. I'm here with Maria Loreto and Karina Zornoza, and we're going to talk about nanorobotics. Now, before we can talk about nanorobotics, we will go through what is nanorobotics, its history, its current uses, being its pros, cons, the theory behind nanorobotics, the future of it, our proposed design, and finally we'll wrap it up at the end. Now, what is nanorobotics? As the name would indicate, it is both nano and robotics. So it incorporates a robot at a nanoscale. A nanoscale being a nanometer. A nanometer is about the diameter of imagine the diameter of a marble compared to the diameter of the Earth. The Earth is a meter, the marble a nanometer. Now combining these, you have the manipulation of atoms, and here we see an atom car, thus a nanorobot. Now the history begins with nanotechnology. 4th century Romans used this in a Lycurgus cup. Now this is a cup manipulated with gold and silver ions. This would then change the chemical composition of the glass, thus being nanotechnology. Nanorobotics was not first mentioned until in the 50s by Richard Feynman in this Plenty of Room talk. In this talk he talked about how atoms could be manipulated in the future to perform tasks at an atomic level. Next we have Norio Taniguchi coined the term nanotechnology, which would be used for nanorobotics. Next, we move on to two Swiss researchers by the name of Heinrich Rohr and Gerd Binning. Now, these two researchers, they worked for IBM, and they made an STM, or a scanning tunneling microscope. This was used to see molecules at an atomic scale, and thus they were able to manipulate them. Likewise, we have Erich Drexler, who was a researcher from MIT, and he believed that these nanorobots would be able to self-replicate and thus become self-sustaining. Here we see Lycurgus cup transitioning from green to red when exposed to light, and these are due, of course, because the chemical composition is changed. Next. And here is the STM, as mentioned before, by the two IBM researchers. They created this in 1981. If you were to get one today, it ranges about $3 to $4 million, and FIU does have one in their Emory. Next. Here we see what they did. They made an IBM sculpture, one could call, made of xenon molecules on a nickel base background. Next. And next will be Maria Loreto to talk about the theory and further nanorobotics.
As of today, there's barely any nanorobots functioning due to the complexity in design and manufacturing. Basically, they're all in the research stage, but they have very great future potential applications in the medical, manufacturing, and environmental field. So far, there are many pros and cons to it. Most of the pros being in the medicine and healthcare field. They have very useful applications such as the non-invasive surgery, the localized drug delivery, personalized healthcare, and cures at a cellular level. The main con being the high cost, the design limitations because of the size of the nanorobot, and there is really no efficient manufacturing method so far to manufacture at such a small scale, as well as the intelligence to control the nanorobots. And in the medicine field, any small inaccuracy in these robots can be fatal. In the future, we can see developments such as medical, healthcare, environmental, and the manufacturing field. In the medical field, we have bio-nanorobots, which consist of nanorobots made up of biological components such as protein and DNA. Protein is mainly used as natural machinery that can, such as motors and anything that can cause any force, motion, or signal. DNA so far is mainly being used for links and joints since they don't really have any function that could be used for natural machinery.
Another future development would be surgery, mainly cardiovascular disease. So there is a micro swimmer robot now being developed and actually manufactured, still in the research stage and the testing stage. It can actually be injected into the artery that needs to be unclogged, relieving that cardiovascular disease. It's actually a chain of magnetically charged particles that can be controlled and guided by external magnetic fields. And ideally, they will biodegrade after the procedure is done. In the healthcare field, they can also be applied for potentially curing deadly diseases such as cancer and HIV and AIDS. In the cancer industry, they can be programmed to seek out and kill the cancer cells. As well as in HIV, they can also be programmed to seek out the white blood cells, but to actually have cellular surgery on them to reproduce them more in order to balance the immune system. Also, gene therapy, which is the replacement therapy of chromosomes that needs to be changed out, as well as the regenerative medicine, which is to restore lost tissue or create new organs to replace either a kidney, liver, etc. And diabetes, it can be targeted to balance out the insulin levels in a diabetic. There's also an app being created to work with the nanorobot in order to balance those out automatically. In the mechanical area, these nanorobots are being created as a structure using bearings and gears in the very small scale, nanoscale. In the future, they're being looked to be implemented in the mimicking of human beings. Next, we will talk about dentistry.
Now, in dentistry, there are many potential ideas for nanorobots. Nanorobots could be used as similar as mouthwash or toothpaste. They could be ingested, be safe to the human body, and kill bacteria, plaque, as a normal mouthwash or bacteria would do. Likewise, these nanorobots could also be used to apply anesthesia for surgery. Now, anesthesia today is very just generalized and just given to a certain part of the mouth, but with these nanorobots, they can be applied directly to the tooth location and for surgery. Next, we have cavities, which could be used, could be filled in by these nanorobots. Thus, these nanorobots are very diverse in their abilities. Furthermore, we have environmental concerns with these nanorobots. These nanorobots could be used to clean the environment, whether it be in the ground or the ocean or any kind of environment that has metals or foreign contaminants. Now, there are ideas for a graphene oxide-based nanorobot, which would be used to clean the ocean. Now, graphene oxide is very attractive to metals. They attract metals really well, including lead and other toxic materials that can be found in the ocean. Now, with this being done, these nanorobots will be used to clean the ocean. Of course, this is just potential ideas. Okay. Here we see these nanorobots in action, the green being the metals and the lead, and the black mesh being the nanorobot in the water. Next, Karina will talk about the acne proposal for nanorobots.
Our proposed concept is an acne treatment. Acne affects 80% of the people between 11 and 30 years of age. Now, if we were to create a nanorobot that can effectively treat, prevent, or even cure acne altogether, it would be highly profitable and effective as well as accurate.
To summarize, nanorobots have a lot of very useful applications in a lot of fields, but are currently in the very early research and development stage, so we will not be able to see them in the foreseeable future. Thank you.